Hi and welcome to Week 10's project. This week I'm going to demonstrate how carbonation works and we're going to have a go at making our own fizzy drinks using citric acid and bicarbonate of soda. Citric acid is found in lemons, limes, other citrus fruits. If you can't get hold of it, that's fine, you can use vinegar as well, though citric acid is slightly more acidic. This is a classic chemical reaction. There's loads of videos on YouTube about people making gas-propelled rockets or cars, and seeing as though we've already done both, we thought we'd do something a little bit different this week. When you mix citric acid and bicarbonate of soda in the presence of water, the two react to form sodium citrate, water and carbon dioxide. There are two key things that I want to draw your attention to. First of all, the reaction is endothermic, meaning that it absorbs heat from the surroundings. That will mean that the surroundings and the environment that it's in will appear colder as it's drawing in heat from the environment. Secondly, the reaction produces lots of CO2. Now we can use that in a variety of different ways. We can bubble it through drinks, as we're going to do, or we can use that buildup of pressure to power something, like I mentioned before, a rocket or a car, anything like that. We're going to start by demonstrating the reaction in a bowl, so you can see what happens. So we'll start off by taking some sodium bicarbonate, and we want a level teaspoon and a half. To 1 teaspoon of citric acid. And that goes in there. So you can see the reaction hasn't started yet, and that's because we need to introduce water to this first. You'll notice that the water, as I mentioned before, I've dyed it blue just so that it's really clear what's happening. And the bubbling that you'll see when I introduce the water is due to the carbon dioxide being released. So I'm going to introduce the water now, about 50 ml. If I give that a good mix, you'll see that bubbling that's happening, producing a nice bubbly effervescent mixture, and that is the carbon dioxide being released by the reaction. If you've ever done a classic science fair volcano project, you'll likely have used this mixture before, as the effervescing mixture looks a little bit like lava, although not at the moment when it's bright blue, but if you use red food colouring, it'll look a little bit more like lava, and that's sort of an explosive reaction. Now I mentioned before that it's an endothermic reaction, and you can demonstrate this really nicely by making your own DIY cool pack. So next time you overexert yourself on your daily exercise and you find yourself without any frozen peas, have a go at making one of these instead. To make our DIY cool bag, I'm going to exploit the same reaction within a Ziploc bag. Okay, so to the bag I'm going to add, again, 1.5 teaspoons of sodium bicarbonate, to 1 teaspoon of citric acid. Okay. You can of course use more, but you have to be wary of the gases escaping from the Ziploc bag. To this, again, 50 ml of water. I'm going to close that. I might leave a small vent in the top there. I'm going to give it a real good mix. Probably add a little bit more water actually. The rest in there, so about 100 ml of water. Give it a good mix. You'll see that the gases are causing the bag to inflate, and it's also cooling down significantly. If I had a thermometer to hand, I could measure the drop in temperature. I don't happen to have one, so I'm going to have to skip that phase, but please do at home. Give it a try with a thermometer, see if you can measure the decrease in temperature. And there you go, there's your DIY cool bag. Really easy to make out of some stuff that you'll have lying around. Now it's time for the Drinks Carbonator. Now, unlike some of the other previous videos, this will require a few more unusual items. For this you're going to need 3 plastic bottles, some plastic tubing. I just picked up this aquarium tubing from the local pet shop along with this one-way valve. It's good if you can get these. If not, you can use, instead of the tubing, some plastic straws, but you just got to make sure that those seals are really tight. I'm going to use a glue gun just for ease here. You can use, again, different adhesives, but the glue gun should make a nice seal. We've got our sodium bicarbonate, our citric acid, water, and really importantly, eye protection, just in case you misjudge the amounts of gases that are going to escape from the bottles there. You also will want to use a space that is easy to clean, so you'll notice that I've been in the kitchen today rather than at my desk as usual. I'm going to protect the surface from the glue gun just with some spare card that we had there. It will take a little while to heat up. So I'll leave that there while I wait for that to heat up. While I wait for the glue gun to heat up, I'm going to prepare the bottle tops. So I've got a chopping board and my bottle top. I'm going to use a sharp knife very carefully to make a hole in there that I can feed the tubing through. So very carefully find the midpoint there, make a small cut. You will obviously for this, like all our videos, need adult supervision, so you get them to do this part. Very gently work it around until you've made a small hole in the lid there that you can feed the tube through. What you then want to do is feed 2 lengths of tubing through the 3 lids. We've got one length which is 45 centimeters and one which is 35, but it'll depend on the size of the bottles which you use. We're going to use the glue gun once it's heated up to seal those gaps around the edges there. You can see that I've already started on this one at the end. You can see that the glue gun is ready there, so I'm going to pop on some gloves to protect my hands. And then I'm going to use the glue to seal the edges there. And I'm going to do the top as well. Like so. A nice seal. It'll take a little while to cool down. And repeat the process for all 3 lids. Now we've let that glue dry, it's time to attach the lids to the bottles. The first bottle will contain water that we'll use to then mix into the reactants. In the second bottle we'll have the sodium bicarbonate and the citric acid, dry mixture, so it won't be reacting as we saw earlier. And then in the third bottle we'll have some squash which we're going to try and carbonate. To the middle bottle we'll add our citric acid and our sodium bicarbonate. This time we're going to use slightly more, 2 teaspoons of citric acid to 3 sodium bicarbonate. And finally in the third bottle we're going to add our squash, and we're only going to add a small amount of that in there. We're now nearly ready. I just need to make sure that I attach the one-way valve onto the tube which connects the water bottle with the sodium bicarbonate and the citric acid. That's going to stop any of the gas going back into that original bottle and direct it all where we want it to. We can then screw on the lids. Making sure that they're nice and tightly on. We can use a rubber band or a balloon to help improve that seal if you've got any at home. Really importantly, note that the tube here is submerged underneath the water, underneath the layer of the squash. If it was out there, we're just going to end up carbonating the bottle rather than the actual liquid. So that's really important that the tube goes under the water. This is all now ready to go. To start the reaction, we'll squeeze this bottle, forcing the water out into the mixture of citric acid and sodium bicarbonate. As we saw before, that will start the reaction, start the production of CO2. It won't be able to go back into that original bottle, because of the valve that we've placed on, so it will then be forced out into the third bottle and hopefully we'll start to carbonate our drink. So let's test it and see whether it works. I think it's time for the taste test, so let's see how well it's done. Few bubbles, but not very many. I can taste the carbonation, but I can't really see the carbonation or hear it, so I think we might have to repeat that process a few times. It does taste like very flat, once fizzy drink, but I don't think I'm going to be rivaling any other major soft drinks manufacturers just yet. I think I need to play around with those ratios a little bit, so maybe try a little bit more sodium bicarbonate, a little bit more citric acid. I was very cautious with the quantities that I used though for good reason. I didn't want to blow up the kitchen, but now that I know we need a little bit more, I think I'll go back to the drawing board and try a few different things, try a few bigger quantities. And now it's time for you to have a go. Change those quantities, but please do stick to the ones that are in the booklet. Share any results with us using the hashtag engineeringathome. Best of luck.